Okay, this is managing complexity with NGRX. My name is Brandon Roberts. You can find me on Twitter at Brandon T. Roberts. I work as a developer and technical writer on the Angular team. We're writing guides, tutorials, and development for Angular.io. Also a maintainer on the NGRX project, which of course is what you're here to learn about. As I mentioned before, you can find me on Twitter. I press this up front. I post a lot of tweets and tweet a lot of GIFs. I talk about sports and basketball. It's basketball, and I block people because I'm on Twitter to have fun. So NGRX is open source libraries for Angular. It was founded by Rob Wormald. The purpose of the library is libraries built with reactivity in mind. Primary libraries are about state management and side effects, and there are other additional libraries that handle collections, router integration, and schematics. It's also a community-driven project. We have a lot of community contributors. We did some collaboration with this.media and Applitools to integrate visual testing, and we also take welcome contributions. One of our contributors that did the visual testing is sitting right here, which is pretty cool. So if you ever want to contribute to the project, and you can visit our GitHub page and get involved. So the focus of this talk is focused on a paper from Ben Mosley and Peter Marks, and it talks about complexity, and complexity being the single major difficulty in the successful development of large-scale software. So before we talk about this complexity, I want to clarify what we mean when we talk about a large-scale application. So if we look at this scale, it just has 2 points on the scale: duration of the project, size of the team. It's just a function of time spent supporting the project and the size of the team. So if you're a solo developer on a really small team and you aren't spending a lot of time building and maintaining the software, then you're probably what would be considered to be working on a small application. However, you take a small team and ask them to work on this same project for a while as it's going to grow, or if the team is a little bigger, the application is going to grow. So this starts to move applications into the medium category. So how do we get to large software projects? Really big teams or projects that last a long time end up being big in this case. You don't necessarily need to be on a large team to experience some of the same problems that come at this scale that massive teams have to deal with. And just to remember, there's always bigger projects. There's always bigger systems. There's always bigger software to take on. So even if you think you're working on a big project, of course, there's always bigger projects out there. This isn't meant to diminish smaller projects. It's okay if you aren't working on large scale, but because all software has its own challenges. And it's just that large scale software has a different problem set. So going back to the quote, we're just going to focus on the challenges of building large scale software, and the complexity being the single major difficulty in that successful development. So in the paper, the author is going to contribute 3 major factors to this complexity: the management of application state, the volume of code in the application, and complex control logic, or complex control flow logic. So I'm pretty sure how many of you seen phrases like this? Try it again, refresh the page, this is the classic Windows quote, try turning it off and turning it on again. Yep, works on my machine, that's another one. Reinstall the app or re-download the app. Those are pretty acceptable, right? Pretty acceptable in most cases, but generally this is not fine when we're dealing with complex systems. Those phrases are are very familiar because we work with applications, or we have to deal with applications that have errors in the way they handle state. This is the quote unquote tar pit that they're referencing. If we want to build large scale applications, we have to be deliberate, have to have a deliberate strategy about how we're going to handle that state. And that's where NGRX comes in the context of Angular. So we're going to talk about how to manage state, the code volume that comes along with that, and how it allows you to control the workflow when you're building these apps. So the first one we'll talk about is state, of course, because that's when you're dealing with complex applications that have a lot of moving parts. Those are that's the area you're going to focus on the most as far as making it follow along how the application is supposed to flow. So we're going to use an example from a friend of mine. His name is Lucas Rubalkey, because has a good illustration of how you think about how state has evolved in your applications over the years. So this probably looks familiar. This should look familiar to some of you. I know that I've written some jQuery code like this before, and that code is probably still floating out there today, and it was perfectly fine. But in this code, there's state around whether or not a modal is open. So that state is like intertwined with the template. We're capturing clicks, we're capturing behaviors. All the behaviors about the state changes is here too, about how we're updating the modal. And this code back then was the best we had at the time, but it often became difficult to maintain. And a big reason for that was because how close the view layer was of our state and behavior were. So we fast forward, along comes AngularJS, and it introduces the concept of controllers. Now we have our state and behavior isolated from our template. So we're doing better here. We're not coupling them all together. So that brought us that first bit of separation. So now we have a clear view layer and a place to manage state. As with everything else, we continue to evolve this concept. Angular apps, we've talked about lifting this behavior and state out of the controllers, or components as we call them, into shared services or feature services. Now the state and how it changes is encapsulated in this service. So we're managing the authenticated user in the auth service as opposed to directly in the component itself. So now we're moving further up the stack. We're moving the state further away from the view layer. And so our code becomes more and more concise. Services are just reduced to just state and behavior. So how can we isolate it further to just state? That's where NGRX comes in. NGRX gives you a framework, building blocks. One of those called reducers is shown here for adhering to the single responsibility principle, which means we're isolating these sets of responsibility. We're isolating the set of responsibility of managing state into a single block of code. There's no behavior in this reducer. It's just clear descriptions of how and why state changes. So now we've lifted the state. We've gone from state being tightly coupled. We've moved to state being in services, and now we've lifted the state out of services, so it's further away from the concern of our template than ever before. So we keep progressing. Now we can use these, since our state is no longer coupled to our application, we can use these shared features to share this state across components and services, but also across applications. You could share state across an Angular app that's running in the browser, or an Ionic app that you've packaged up for an app store, or different sets of apps, because you still have that same set of common functionality that you're managing with that state. So another win from this isolation is testability. We now have a straightforward strategy for testing our application that makes the right state transitions. for our auth-reducer example, we can show that you start with initial state, you pass some kind of action, and then we can assert against the result of that state change. And this is all done outside of testing the component itself or the service itself. So just to enforce that, the mental model, state is decoupled from behavior. Changes to state are deterministic. We use reducer functions that are pure. They don't have any side effects. You pass an input, you provide them an input, and you always get the same output. And you get that straightforward testing strategy that I mentioned. So NGRX gets you out of that pit of managing a complex application state by moving that state, that responsibility of managing state out of your components, out of your services, and your components just become a reflection of that state, of shared state that you need. So the next part is talking about code volume, and this is something you just can't get around in most cases. So does NGRX reduce code volume? I wish I had to be honest about this, because it's one thing that always comes up with using NGRX versus just using services and vanilla RxJS or just regular services on their own. And this is one thing we always get dinged on, is boilerplate. You have to set up these things. I've talked about these things that you have to do as far as actions and reducers, but they have a purpose, and NGRX is going to increase the code volume of your application. But in doing that, it's helping you to manage state and manage the control flow. So think of that as the cost of using NGRX as opposed to using a different solution. And if you find it, there are other solutions out there, but this is the the flow that NGRX uses to manage state and to help you manage state. So if we really take a look at it, boilerplate is not really the right word for what NGRX provides. It's explicit code. Usually what happens is developers don't like because NGRX wants you to be explicit about how you're building an application. Actions are for expressing events, and reducers are for a shared state. And we have to be explicit about that because it gives you a pattern and a model that you can follow when you're building out these things. But we could go through, talk about the code volume that NGRX that you have, but the ways that you can go about using it for your benefit. So first, we'll talk about actions. And actions are the foundation of applications built with NGRX. So in an NGRX application, an action is a unified interface for describing any event that happens in your application that deals with shared state. These events come from a variety of sources, such as user interaction, communication with the backend, or interfacing with browser or device APIs. As you can see here, action has a minimum type and any additional properties that give that action context. So there are the rules when writing these actions or concepts are that they should be event-driven. By capturing events that happen in your application, we're making a separation between a description of an event and handling of that event, as opposed to that being directly tied to a component or service. Actions should be descriptive. They are meant to be narrow and targeted. There are many unique things that happen in your application that you're expressing these events for, and that's why those actions need to be specific or descriptive. They also need to be specific. Generic actions don't provide you any glanceable information that you can use, which makes tracking down problems harder. And it helps in debugging when you know where the action came from. And this is one of the things in NGRX is each action should be a unique action. It It should only come from one place. That way you can easily trace back to where the result of that action happens. It's easy for actions to be handled by multiple reducers and effects. As we talk about state changes, actions, like I said, actions are going to be throughout your application, and reducers and effects decide how those actions are handled. The producer of those actions is to express an interesting event that happened. And lastly, side effects. As I talked about before, these are most commonly API requests, or it could be dealing with, like I said, browser APIs and other APIs that you'll deal with when you're building these apps. So write actions first. Actions are cheap to write, and they provide a lot of value. We provide DevTools integration, so it helps you there, help with debugging. And if you're working with NGRX and you're working on a team, to write out the actions first, it helps you model these flows and helps your team build an understanding of these unique events that happen for a given feature or your application in general. So we recommend using the source event pattern with defining action types. Pick really descriptive names for these sources. If it's from an interaction with a component or page, include that in the description of the action or the action type. If it's from an API call or query, they're cheap to write, just make that clear. Event names should actually describe what the source did. So we can take a look at a set of examples here about the user attempting to authenticate and the successful action that was returned after that happened. Now these aren't terrible, but they could be better. So if we take a look at a better set of actions, you can actually see where these actions came from. The user attempted to click the login button, the login page expressed an event, or the API returned a login success. So those are the tips about writing actions, but we still need to categorize them so we can still have that glanceability of where they were. So there are three main categories that actions go into, and you can divide these based on their event source. User actions are going to be the ways a user interacts with the app, clicking on a page, or navigating around, clicking on buttons. Divide those up based on what the user is going to be doing. Backend actions are going to be dealing with API requests, whether it be a WebSocket connection, a REST API, or GraphQL. They could be GraphQL queries. Device actions are going to be the result of working with side effect producing behavior or browser APIs. So you can divide those based on the API that you're working with. So whether this be a WebSocket or IndexedDB, or these things that come from many different sources that you're putting in one place in your state. The second consumer, or another consumer of actions, are reducers. So a reducer is just a pure function. It takes every action that's dispatched to the store. It defines an initial state, and that's just the initial value that you want that state to have. And it takes the most recent action in the most recent state and returns a new state. And this is and also new states are looped back into the reducer, so that the next time this cycle happens, we'll always get the last state that is produced. And this is intentional because we're making these changes to state in an immutable way, which means that we're not modifying the current value and returning that. We're producing a new value and using that because in your Angular applications, you can take advantage of this using the async pipe, which checks for these reference values, as opposed to checking these objects, checking each property on an object, doing deep checks. So by doing this in an immutable way, this is familiar with how change detection works. these state changes, we can key off these state changes for change detection. So here we have an interface of a state that includes movies. So we can look at how we would manage the state of this with a reducer. So this, there's a reducer function that handles that shared state, loads the movies when the success action is dispatched. We have a create reducer function, and this is just provided with NGRX to give you an easy path to create these reducers. As I mentioned before, each reducer has an initial state. In this case, we're managing movies, where it be an empty array or an object. It just depends on what the shape of your state that you're managing is. But this case, it's just be an empty array of movies. We're associating these actions, associating each particular action with a state change. So in this case, we're saying when movie is loaded, success event happens, we want to handle that action using this on method that's in the create reducer. And then we want to return a new state. As I mentioned before, we have the current state, which will be empty at first, and then the current, and then the action, and then we could populate the new state with the set of movies that we want to update. So just looking at it as a whole, we have a way to express how the state of those movies would change using this reducer function. Next, we'll talk about selectors. And selectors are the reducers are managing state changes. Selectors are more for getting data out. And selectors are one of the best parts, in my opinion. But we'll talk about what they are and give some examples of how to use them. So, I guess for anything else, we define what are selectors. Selectors are kind of like this. They always get a piece of application state, and selectors provide that data. But selectors are really, at the end of the day, they're just functions. They take your state is one big object at the end of the day with a lot of different data structures in it. And selectors help you get that data out. There are two types of selectors, getter functions and deriver functions. Getter functions are simple. They just pick off properties of your state. So if you look at this login page state interface, it just has two properties, and we could use a selector just to pick off the pending property. So as I mentioned before, a selector is just a function you provide it. When you're using the selector, you're taking a piece of that object off and just returning a new value. So here we're selecting the login page state, or receiving the login page state and returning pending. You can also derive state using selectors. And derived state is state that already exists in your application, or a state that you're already managing, that you don't have to include additional data to glean information from. So if we look at the user model interface, it has a few properties, ID, name, email, and active. And if we wanted to add a couple more properties for account and active users, we could add those here, but we don't need to capture all those properties separately. The selected user model already exists. What already exists in this state, the number of users already exists. The active users already exist. So we can remove those additional pieces of data, or have to manage those additional pieces of data, and use selectors to reference them. If we want to retrieve active users based on the collection of users, we can write a selector for that. We filter over each user and look at the active property. Another example would be deriving the total number, users total. We already know how many. We could build these selectors together. We could select all users and then just return the length of users in that array. More complex data is done by combining these selectors together. So I talked about before, we have a user model that would be returned from the back end upon successful authentication. The auth state will capture this user model once authentication is successful, and withhold any additional properties. But we don't have a notion of being logged in specifically defined here, because whether the user is logged in or not depends on the information we already have. If the user property is defined, then we can derive that using a selector. The user logs in, the user is populated, and we're turning that value into a Boolean to determine whether the user is logged in or not. When a user logout event happens, we clear that user, and that information or the return value becomes false. So also use selectors to compose data. And as I mentioned before, you can use these smaller selectors to make more complex data structures or substates, as I call them. So here we have an interface of books and users. Now, whether these pieces are loaded lazily or eagerly really doesn't matter in this case. Selectors, once all that data is there, selectors combine them to produce new data. So if we look at this example of selecting books, it's similar to selecting books. We select the top level book state, and then we look at the property in our state that selects the collection. And we also have libraries that manage some of this for you. Another one's called NGRX entity. But in general, we have a selector here, and we could have another selector that could select the current user. And we could combine those two sets of data together to return each book for the user's map for a given user, or the books for a given user. So we're deriving new sets of data based on selectors that we've built up. As I mentioned before, selectors are building blocks. If we wanted to take this data a step further and combine a current user, their books, and their favorites, we could all do that efficiently and in a reusable way. Because these selectors are built, and one additional thing is these selectors are built with memoization, which means that they remember the last value that they used. So even if a state changed, if it does not impact the result of this selector, then the selectors won't fire. The last part the last portion of the code volume is a library that we provide for. It's called schematics. And schematics provides automation for repetitive tasks, like the real boilerplate things that you have to deal with when generating NGRX features. Because they are files to maintain, and schematics take care of the work that you don't want to do. So instead of having to type out things by hand, you can still get along quickly and get to work with NGRX in a consistent and predictable way, which is especially useful across teams because you can standardize what the result of those schematics are. So as I mentioned before, schematics are code plus templates to help scaffold out files and perform tasks. So an example schematic right here that's included with NGRX schematics would be to generate an auth feature. And this auth feature would help you to generate the feature state, wiring up effects, or add existing features. So when you run this command, as I mentioned, it would generate these things for you that you need to build a given or start a given feature. The initial actions that you need, the reducer setup, the effects, and wiring up any existing Angular or NG modules. So as I mentioned, we're thinking about NGRX in terms of code cost. It gives you a set of great guarantees to help with maintainability, performance, debugging, and testability. But that does require a code cost. And so we don't want you to think in terms of boilerplate when thinking about NGRX, but in terms of what the benefits that you get from that additional code that you have to write. just being more explicit about the application code that you're going to write to use it. And that goes to the last part when we're talking about control flow. So control flow we describe as behaviors that cause the state to change. As I mentioned before, we go back to our authentication reducer. There's no behavior in this reducer function. We can see that reading the state changes when a user logs in or logs out. And that's its behavior. The actual act of logging in or out is the complex part of that control flow. And that's handled by effects. So in NGRX, we manage these, like I said, these are effects, we manage them. They're just specialized Angular services. And most we call them the brain bender because that's what happens the first time you use them. That's the pretty much was my first encounter with them also, to be fair. So we looked at this diagram before, and we talk about where effects fits into this this area. And effects are, they're side effects. They are independent processes separate from your reducers and container components. As we mentioned before, reducers can listen to multiple actions, and effects perform that same task, but they have a different responsibility. They listen for actions, perform some kind of behavior, and optionally dispatch new actions back into the system. So effects receive actions that express the intent of the user. Using the specialized operator, the of type, and the actions observable, we can listen for any action that occurs in the application. When the actions are dispatched, the effect that's interested in that particular behavior is listening for it, and then it, in this case, we're switch mapping into a different observable to reach out to a backend service. But that's not the only thing that you can use these for. As I mentioned before, you can use them for WebSockets or device APIs or anything that you want to isolate from your components. When that behavior completes, in this case we're looking for movies, it results in a new action, and this is dispatched back to the store to continue that cycle and allows you to model complex behaviors using actions and observables. So the responsibilities of effects. They are processes that run independently of your reducers, excuse me, and your components. They connect, excuse me, they connect your application to the outside world. They connect by running behaviors or simply communicating with your services. And as I mentioned before, they're written using observables. So there's nothing, if you're comfortable with using RxJS observables, then using effects will be just an extension of that. So I would still say that you should have some level of comfort using streams or just thinking in a reactive way to take a lot of advantage of effects. So effects allow you to model control flow using observables, and by modeling those behaviors independently of your components using observables. So those are the things that help you get out of the topic that I talked about of managing control flow logic with NGRX. So I'll go through a quick demo, or at least talk a demo and talk about the different parts that I mentioned before. So here I have, okay, it's not going to show my thing here. Let's see. Okay, and we're back. So here I just have a page that's displaying a set of books. And I will open, I'm just going to flick out again. Okay. I guess it doesn't want me to show books. Okay, I'm just not going to touch it. I'm just going to talk about it. So here I'm showing just showing 3 books here, and these books are being managed in using NGRX in a shared way. And I will try to slide over this tool here. Don't go back again. Okay. So as you can see, we're managing the state of these books, and I've expressed these different actions that happen when you're managing these books. So when you enter the books page, we have an enter action, and then we have side effects, an effect that's running in the background that would load these books, and then we have an action that tells you when that sequence happens and these books come back from my external API. So you can see the Fellowship of the Ring matches here, and I'm just showing a simple example here of how we could manage the state of those books in a shared way using NGRX, and how you can use the developer tools to track what those books look like. And I messed with it again. Okay. So as I mentioned before, I'll show you a quick walkthrough of the parts that I mentioned before, just kind of in an abstract way, but we can show you something more concrete here. We have the books page here that shows you that actions that we're expressing, and you see I've divided these into 2 different sets of actions. One for the books page, where we have user interactions or interactions from the user, and also books API actions. And this would be the event that happens when the REST API returns a successful result. So we're categorizing these actions in that way. Also talked about side effects. That's side effects here, where we're saying effects are just special services that allow you to handle asynchronous activity. So here I'm listening for the interaction. I'm using a book service to request all the books, and I'm mapping that into a new action that tells me when the books are loaded. I also additionally catch errors here and return some other action that that we could use to change the state to notify the users that the retrieving books was unsuccessful. So all this would be effects of where you would handle this asynchronous activity. And then we have our shared state, our books reducer, after the quick flash. And then as I mentioned before, we have our state that's managing our collection of books. We start out with an empty array for our initial state. And then when the books loaded action happens, then we take our existing state and return a new object to let our application know that an interesting state change has happened that we can key off of. Flash. Almost got the timing right. Lastly, I talked about before about the async pipe in Angular. So we use a selector to select those books, and that way the component itself, as you can see here, doesn't have much responsibility. Okay. The component doesn't have a lot of responsibility. We can select books and dispatch actions to express events. And if it'll come back up one more time. And lastly, I mentioned the async pipe. it's subscribing to the selector in our component, and we're not having to do anything extra there to let the UI know that it needs to be updated. So lastly, NGRX works well for large applications. State is fully decoupled from behavior. There is a code volume factor that you have to deal with. And we model these control flow using observables. And just to drive that home, it's well suited for large apps and difficult, complex projects. Thank you for having me. As you can see here, you can go to NGRX.io to visit our documentation site. And as mentioned before, you can visit our GitHub page. You can visit this page. It has all our documentation on how to get started. Also has links for contributing if you want to get involved, or visit our GitHub, like I said, visit our GitHub page and see more about what the project is. Thanks.